In this problem, there is a vertical spring with a certain mass attached, and it's pulled down and allowed to oscillate up and down. And we want to know if the period of that oscillation is 0.5 or 0.75 seconds, what the spring constant of the spring is. So we have a relationship that involves period, mass, and the spring constant that we just learned in the prior lecture. The fact that the period equals 2 pi times the square root of the mass over the spring constant. So I can plug in the period and I can plug in the mass. And now I'm going to solve for the spring constant. So the first thing I've done here is divide by 2 pi. And you have to be very careful when putting this in your calculator. And when you divide by 2 pi, that you put a parenthesis in front of the 2 and behind the pi so that the 2 and the pi stay together, because it's very easy in this step to divide by 2 and multiply by pi, because the calculator doesn't understand that 2 pi is supposed to stay stuck together. The next thing I'm doing is squaring both sides. So I've squared the 0.119 in order to get 0.0142 seconds squared. And squaring both sides cancels out the square root, so we're left with 2 kilograms over the spring constant. The next step is also a little tricky because you have to be careful not to find the inverse of the spring constant. So I'm going to multiply both sides by k to bring k up to the numerator on the other side, and then divide by the 0.0142 in order to isolate k. So when I take 2 divided by 0.0142, I get 140 newtons per meter as my spring constant.